Okay, Trig, we're going to do like the first half of section 1 for today. Here's the homework for it. But I had Sienna and I think a couple others say, can you do homework problem number 100? And that's kind of a difficult one. There's an A, B, and C to it. I said, absolutely, sure. So here is homework problem 100. This is from 1-3 homework. And on each one of these, we're finding the domain. So A, B, C, I've written them out here. We'll go through each one of these. So here is the first one, okay? And I'm just going to put like a little reminder as like the two things that we're looking for, the things that mess up a domain errors. Number one is a negative inside of a square root, and number two is dividing by 0, or vice versa, whichever way. I don't remember what order I put them in before. But when we're looking at like this first one, part A, we are interested in making sure that number one doesn't happen. We don't want to have a negative inside of a square root, okay? And this one's a little bit more tricky than just dividing by 0. In that the first thing we have to do, I think I told you that it has like a couple steps to it. So like number one, I set the inside equal to 0. And then number two, I plot it on a number line, okay? Because like if you do that, like you can't make a mistake, right? So the first thing that I do is 16 minus t. I set that equal to 0, okay? Now, normally you'd maybe move the 16 over, but I'm going to add the t over. So 16 equals t, and this is what's like my critical number, basically. So I'm going to put 16 here, and I'm going to test like a point over here, and then I'm going to test 16 exactly to see what it is we're looking at, okay? So like a number that's on this side of 16, you could use 15, you could use 14, you can use whatever you want. I always use 0 if I can, right? And then a number on this side, let's go ahead and do 17, whatever. It doesn't matter. It doesn't matter what your numbers are. You're going to end up with the same pattern happening. So if I plug 0 into this equation right here, I have 16 minus 0, which is 16, and the square root of 16. That works. That ends up coming out actually even not as a decimal, right? It ends up coming out nicely. So this stuff works, all right? Now, if I plug 17 in, I'll have the square root of 16 minus 17. And 17, like if I'm subtracting 17, I'll end up with the square root of a -1. And I cannot do that because you can't have the square root of a negative. Now let's look at 16 in general, just 16. If I do 16 minus 16 and I take the square root, can you take the square root of 0? Sure, you can. A lot of people say, no, you can't. Yes, you can. You can take the square root of 0. This just means what do you take times itself to get 0, right? It's 0. So basically you have a solid dot on 16, and then this is your answer solution, right? I don't know if they have you write it as in interval notation, but this in interval notation is negative infinity up to 16 with a bracket, because you can have 16, and it will look like that. So that is the answer to part A, okay? Part B is going to be similar to that. I'll pause there for just a second so you can get that guy written down. Part B is similar, but it's t minus 16 instead of 16 minus t. But I'm going to still do the same steps. The first thing I'm going to do is set t minus 16 equal to 0. And if I add the 16 over, t is equal to 16. That's going to be my critical number again. Okay, so I'm going to slap 16 on a number line. I'm going to do the same points. I'm going to test 0 and I'm going to test 17. Okay, so in this case, if I plug 0 in, 0 minus 16 ends up being a negative 16, and you cannot take the square root of a negative. So over here, this one does not work, right? But 17, if I plug 17 in, I've got 17 minus 16, and that is the square root of 1 if I do that. And that ends up working, right? So then I just have to check 16 itself. So 16 minus 16, if I do that, the square root, that ends up being the square root of 0. And we just said that that does work. So it's like a closed dot with an arrow to the right. And we are going to then write that in interval notation. So that's going from 16 to infinity is my answer solution. That's always a parentheses, but this one is going to be a bracket again. Okay, so that's going to be what my solution set looks like. Okay. All right. And then this last one is kind of a double dose. He is a super doozy because we have both things happening at the same time. We have to deal with the negative inside of the square root, but then we also have to deal with the fact that we have a bottom right here now, right? Like I don't want this bottom to be 0, okay? So let's deal with the harder one first. Let's deal with the fact that we don't want a negative inside this square root. So I'm going to do, just like I was doing before, 16 minus t equals 0. That means if I add the t over, right, this is similar to what we did in part A, 16 equals t, right? This is going to be the same equation as part A, right? And we got, I'll just show you all the way through. I'm going to do all the work again, right? So 16 again, if I slap him on a number line, right, that's my critical number, okay? I'm going to plug in 0 and I'm going to plug in 17. Doesn't matter what numbers you plug in, just as long as like one of them's on the left of 16, one of them's on the right of 16. And then I end up testing these numbers. So if I plug in 0, I end up with the square root of 16. The square root of 16 does work, so I'm going to circle that. If I plug in 17, I get 16 minus 17, so this is the square root of -1, and I cannot have that, right? If I plug in 16 itself, right, 16 minus 16 is the square root of 0, and I can do the square root of 0, right? Like this would be a closed circle, except for the fact that in this problem, this guy right here, we do not want to be equal to 0 because he's on the bottom, right? That's where the second domain error comes into play. I do not want that to be 0. So if I have this scenario, then I will end up with 0 on the bottom. So instead of this being a closed circle, he's going to actually be an open circle on 16, okay? And I can have this stuff. So I end up with like basically 16 here, open circle to the left. That's what makes him an open circle, is because normally I could, with a square root, have 0 in there. But the fact that that's a bottom makes it so I do not want that to be 0. So my solution set is changed a little bit, and I go from -infinity to 16 and parens on each one, okay? So that letter C was just kind of a double dose. We've just got to kind of consider both of them at the same time. I still worry about the square root first because he's a little bit more work than the other one. And he kind of like runs over into worrying about dividing by 0 pretty easily. So that is what my solution region, I guess, will look like. Okay. All right. So hopefully that helped. I'm going to go into, like, I feel like chapter 1 is still kind of chapter R, really, honestly. Chapter 1 has been very much a review as well. But we're in 1.4. We're talking about linear equations and linear functions. And so, I don't know, we'll get through. I think I'm going to try to get to, like, past example 5. Okay, and then we'll talk about, like, average rate of change or slope and stuff. After that, we'll do that, like, Monday or whatever. But we're going to try to get through example 5. This is all, like, linear function stuff, okay? So starting off, they have just what a linear function may potentially look like, or a linear equation. Linear equation in 2 variables. Typically, we have x and y are my 2 variables, okay? And sometimes our linear equation is written in what's called standard form, okay? And it's like ax plus by equals c. So an example of this might be like 4x plus 3y equals 12. I don't know, something like that, right? Where the 4 is a, this is b, and this is c, right? You have a number in the spots for A, B, and C. Now, that is what's called standard form. Standard form, okay? Now, typically, when we go to, like, graph something, we want it to be in what's called slope-intercept form, and that means we have to solve for y, right? Okay, so what I'm going to do to solve for y is I'm going to toss this 4x to the other side. Okay, so I have 3y is equal to -4x plus 12. I usually put the x first, so it's in like mx plus b form, right? And then I'm going to divide by 3 on everything. And so I have y equals -4/3 x plus 4. This is the same as this guy, except this is in slope-intercept form, okay? So that's how that works, all right? So a linear equation has variables x and y. Each are of the first degree. So x to the first power, y to the first power. Good deal. Okay, graph the line represented by each equation. All right, they have this guy, and I'm going to go ahead and put him into slope-intercept form just like we just did, because that makes it easier for us to graph. So I'm solving for y. I'm going to kick this x to the other side. So 3y equals, and I put the x first, so negative 2x plus 6, divide by 3, and y equals negative 2/3 x. I take this x and instead of putting him on the top, I put him off to the side. So I just kind of slide him off of there. Plus 6 divided by 3 is 2. This is in slope intercept form, okay? Now that makes it really easy for me to graph him because we start with, okay, so slope intercept form, this guy is my slope, and this guy is my intercept, my y-intercept, in fact. So we're going to start by graphing him using the y-intercept first. I'm going to start at 2, and then I'm going to go from there. My slope says negative 2/3. So I'm going to go down 2 and over 3. Now, the problem is I have a lot of people get stuck here, and they're like, which way do I go? Do I go over 3 this direction? Okay, or do I go over 3 this direction? Cool, let's play both of those out, right? If I do that and my line goes this way, right, versus my line going this way, which one is the correct answer? Which one has a negative slope, right? Well, the negative slope is going to be this one. So I know that I need to go that direction in order for that to happen, right? So I'm going to go down 2 and over 3 here in order for my slope to be negative. Now, you can go, if you're one of those people that's like, I have to have a straight line, you can go down 2 and over 3 again, right? Or you could go up 2 and over 3 this way, right? And then that gives you a few extra points to make your line nice and straight. If you're one of those people, you can totally do that. That's fine. Mine's really sloppy, so sorry about that. Okay, that is that function. That's part A. Part B is like, what happens if I don't have a y variable? What if it's just x equals negative 3? Well, this one makes it really nice because x equals negative 3. This is the x-axis, right? X-axis goes this way. So what I do is I go to 3, negative 3 on the x-axis, put a dot, and he's just going to be straight up and down, right? Straight up and down line at negative 3, okay? That confuses some people, and here's why, okay? This is the line x equals negative 3, and they're like, x equals negative 3 can't go up and down because that's the y, right? The y-axis goes up and down, right? Nope, x equals negative 3 means it's negative 3 no matter what the y-coordinate is. If the y-coordinate is 6, the x-coordinate's negative 3. If the y-coordinate is 2, the x-coordinate's negative 3. If the y-coordinate is negative 3, the x-coordinate's negative 3, right? No matter what, x is negative 3. So x goes up and down, right? Now this one, 2y equals 4 if I divide by 2. Y equals 2, and that means I go to 2 on the y-axis, right? 2 on the y-axis is this guy right here, and he is going to be a horizontal line that goes back and forth this direction, just like that, okay? So that, again, that confuses people because that's the x-axis goes horizontal, but y equals 2 is going to go horizontal because no matter what x is, if x is 3, y is 2. If x is 6, y is 2. If x is negative 2, y is 2, right? Every value of x has a y-coordinate that is 2, okay? All right, so that is that. That's graphing linear equations, slope-intercept form, and then x equals y equals. Those are just going to be horizontal and vertical lines, all right? Determining the slope of a line. All right, let's say instead of giving me the equation of the line, they give me these 2 points live on the line, right? Okay, so I know you guys have seen this before. To find the slope, it is the change in y over the change in x, or y2 minus y1 over x2 minus x1, right? Okay, so I'm going to go through this kind of fast. M equals y2, this is like this is like x1, y1, and x2, y2, right? So I take my second second y coordinate and subtract the first one, so 5 minus a negative 2 over 2 minus a negative 3, right? 5 minus 2 is like 5 plus 2, so that's 7, and 2 plus 3 is 5. Now, do not, when you're doing a slope, don't make this a mixed number. Don't write that as 1 2/5. Leave it as 7 over 5 as your slope. You want to leave it as an improper fraction, okay? So that's what he will look like. All right, now this one's a little bit tougher because we have a decimal or a fraction here, but we're just going to write everything out. So y2 minus y1, negative 7 minus 0 over 1 minus a negative 5 over 2. Okay, all right, let's do this here. Negative 7 minus 0 is going to be negative 7 on the top, okay? This on the bottom is going to be plus, right? But I have like a number plus a fraction. So if I want to combine like terms, I'm going to make this 2 over 2, right? 1 is the same thing as 2 over 2 if I do a common denominator. So this is going to end up being 7 over 2, right? 2 over 2 plus 5 over 2 is 7 over 2, 7 halves, okay? Now, the reason why I left it as a fraction like that is because I want to do this. I have a number, and I am dividing by a fraction, right? Number divided by fraction. So I'm going to take this guy, I'm going to make that into a fraction, and I'm going to keep flip him to the top. So he's going to be multiplied by 2 over 7, right? Times 2 over 7. And the nice thing is that these 7s should cancel. So my answer will just be, don't forget the negative, my answer will just be negative 2. Okay. Now you could convert that to a decimal if you want to, whatever, all of the things, right? But negative 2 should be your slope. The slope between these 2 points is negative 2. Okay. Hopefully that was okay. It's just rise over run, basically, is what you're doing. Okay. Just a second. Just got a message. Where do you want kids to go after school? Blah, blah, blah. Funny. Okay. All right. Example 3. Finding the slope of horizontal and vertical lines. All right, I like it. And they put dots on here. That's perfect, okay? So this line, just so you know, this is going through the y-axis at 3. So this is the equation y equals 3, right? Okay, but he doesn't have a slope. Like, what is the slope there, right? So if I look at this and I'm, like, trying to, like, manually find the slope as the rise over the run, let's just, like, play this out right here, right? Okay, rise over run. He is rising from this point to this point, none, right? He is rising 0, and he is running 2 places, right? He's going over 2, and 0 divided by 2 is just 0. So a horizontal line has a slope that is 0, okay? Because he's not rising at all, but he is running some all the way across, right? But then B over here, this is the equation that's going through 2 on the x-axis, so this is x equals 2, right? Okay, if I look at my 2 dots and I look at rise over run, okay, this one is rising 2, but he's running 0, right? 2 over 0, and 2 divided by 0 is undefined, right? Okay, now, this one is going to have undefined slope. Okay, that is the slope. The slope is undefined. Here the slope was 0. Here the slope is undefined. Now, let me give you another little hint to this one, right? If I'm looking at this function right here, which is a straight up and down line, does he pass the vertical line test? No. Like if I draw vertical lines all the way across, whoop, I get to this one and he's hitting everywhere on that vertical line. So this one is not even a function, not a function. So that can help you remember that because he's not a function, he doesn't have a slope. His slope is undefined, right? Okay, so vertical line, not a function, doesn't have a slope. Horizontal line is a function, right? Vertical line test, he passes, but his slope ends up being 0, which is okay, that's fine, but that's just how that works, okay? All right, linear equations and slopes. This has a positive slope, a negative slope. Horizontal line has 0 slope. Vertical line has undefined slope. We just went through all those, right? Okay, all right, applying the slope-intercept form of a line. I feel like I should have, I already introduced this to you back here, and I probably shouldn't have done that, but that's okay. Slope-intercept form is y equals mx plus b, right? M is the slope. Whoever came up with slope-intercept form, like, was really original in their naming, because it's literally the slope-intercept, right? Like, super easy. So here we go. Using the slope-intercept form and graphing the line. We've already done this one. Here I want to put this in slope-intercept form. I want to solve for that y, so I'm going to kick the 3x to the other side. Ooh, x, not y. So 4y is equal to negative 3x plus 4, and I'm going to divide by 4, divide by 4, divide by 4. Y equals negative 3/4 x plus 1. There we go. Okay, now it says write the equation in slope-intercept form. Done. That's part A. Okay, B says determine the slope, and I'm going to call the slope m. M is negative 3/4, and the y-intercept I'm going to call b. B is positive 1, right? M and B, there they are. And then graph the line by using the slope and y-intercept. So I'm starting with 1, which is right here. Oh, by the way, Algebra 2 kids, you guys are pros. You, like, Trig kids know this by now, but like the main thing I see when people are graphing linear functions that they screw up is that like they'll go to here and they'll go 1 right there. Nope, the y-intercept is 1, right? So don't make that mistake on accident. I know that you guys are pros and you are like beyond making that silly of a mistake, but don't do that, right? All right, the slope is -3/4, so I'm going to go down 3, 1, 2, 3, and then over 4. Do I want to go this direction, 4, or this direction, 4? Well, if I do that, then he's going to slope upward. I don't want that. I want him to slope downward, -3/4. Ooh, my line is not straight. Up 1, 2, 3, over 1, 2, 3, 4. There's another spot on my line. Ooh, that's not real great, but that's okay. All right, so there is my function, right? Not too bad. Linear functions, super easy. All right, last one. Example 5, writing an equation of a line. Ooh, I like this one. Write the equation of a line that passes through the point 2, -3 and has a slope of -4. All right, here we go. Y equals mx plus b. Like, you guys know how to do this. Calc kids, we're doing this like to find the slope of a tangent line, right? And then we're writing the equation of a tangent line. Like, you know what you're doing here. If the slope is -4, you're just going to plop -4 in for the m, right? So y equals -4x plus b. And we're going to plug in 2, -3. But be careful. Here's another like rookie mistake. You guys are too advanced for this, but rookie mistake, putting 2 in for y and plugging -3 in for x, because that's the order that they come. No, 2 is the x, -3 is the y, so don't forget to do that. -3 goes here. That's just a thing that I will caution you on. I see that happen a lot, but you guys are too smart for that, right? That's going to be -8. If I add the 8 over, the b is going to be 5. Okay, so I end up with y equals -4x plus 5, and that is going to be the line that has a slope of -4 that's going to touch to -3. Okay, so that is how that works. Got it? Oh, then write the linear equation using function notation. All right, well, whatever. Function notation, they just want me to write f of x equals -4x plus 5. Whatever. Same thing. Okay, so there is that. I'm going to stop there, and then we'll do the other part. I probably could get the other part done, but that's fine. We'll save that for Monday, because you guys have shortened days today, whatever. So there you go. The homework. Oh, did I write down the homework problems? Yes, I did. So you should be able to start and do a lot of those already. Probably a little bit over. I would guess at least till 48, maybe even beyond that, right? So get to working on those. I should be back on Monday. I'm not going to be gone like I originally thought, and that's very, very good news. So very good news. So we will go over and we'll turn all the homework in and we'll do all the things. Not this homework assignment, because we'll still have the second half left, but we'll turn 1, 2, and 1, 3 in on Monday and go through any of those questions that you have. Yeah, there you go. Happy weekend. Good luck to all the sports people, all the things. Goodbye.